Hey, good morning, everybody. We are going to continue talking about differentiation and some different rules that we have. So today we will be able to find the derivative of trigonometric functions. You're going to want that golden ticket printed out and nearby so that you can fill in our trig derivatives as we get there. But before we jump into the new ones, let's talk about some old ones. Warm up, find f prime of x if f of x is equal to x cosine x. Now, don't forget that this is multiplication. This is x times the cosine of x. Thus, we have a product rule. So this is a good review of both a trig function and a product rule. So f prime of x is f g prime plus g f prime. F will be x. G prime is the derivative of cosine, which is negative sine. G is cosine. And f prime is the derivative of x, which is 1. So if I rewrite this, there's not a lot to do to simplify. I'm going to move the negative to the front so it doesn't accidentally look like subtraction and not write the 1. There you go, there's the derivative. There are no trig identities to simplify that with. There's nothing to factor out. That's as good as it gets. Derivatives of trig functions. Yes, you must memorize these. These are the 6 derivatives of trig functions. It's so important to have them memorized. 1, they're not on a formula sheet, but 2, later on, we're going to say, hey, this is the answer to a derivative problem. What was the original question? So you literally have to know them forwards and backwards. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is secant squared. The derivative of cosecant is negative cosecant cotangent. The derivative of secant is secant tangent. And the derivative of cotangent is negative cosecant squared. There are a couple tricks to help you memorize these. If we were sitting together, I would ask you to help identify them, but we're just going to jump right in. The ones that start with C have negative derivatives. Pretty cool. Then I talk about buddies. Sine and cosine are buddies. Tangent and secant are buddies. Cosecant and cotangent are buddies. They all get paired up together. And what's another one? Tangent goes to something squared. Cotangent goes to something squared. So tangent, cotangent go to something squared. And then finally, cosecant has a cosecant cotangent and secant has a secant tangent. So there are patterns there if you look for them. Now, where did these come from? You can derive them from that limit as h approaches 0 formula with different trig identities. Look them up online if you want to. The AP exam will never ask you to derive them. You just have to have them memorized. But if you want to know where they come from, you can look them up. So just a few examples for you today. Example 1, calculate f prime of x where f of x is equal to secant x. So f of x is the secant of x. F prime of x is the derivative of that. I look on my list up above. It's secant x tangent x. Done. That's it. There's nothing else to do. Awesome. For number 2, find f prime for sine of x secant x. So if f of x is equal to the sine of x times the secant of x, these are being multiplied, so this is a product rule. And if you're still getting used to that product rule, it doesn't hurt to jot it down. If you've already got it memorized because you've used it, then don't worry about that. F is sine of x. G prime is the derivative of secant. The derivative of secant is secant tangent. G is secant x. And f prime is the derivative of sine, which is cosine. Is there anything we can do here? Not a whole lot. I'm seeing each one has a secant, so I could factor that to the front. So I have a sine of x, tangent x, plus cosine of x. And that, folks, is really it. There's nothing else to do. So as we learn these derivative rules, keep in mind that they can all be piled on together. They can be used in the same problem. They will be used in the same problem. Trig functions, natural logs, exponents, product rules, quotient rules, and that power rule gets used all the time. So you got to make sure you know them inside and out. I think I've got one more, and this is it. Find the equation of a tangent line to y equals tangent theta secant theta at pi over 4. So I see a product rule, I see trig functions, I see the equation of a line, and I see the unit circle. There's a whole lot going on here. So let's start with, remember that point slope. If you're more familiar or more comfortable with the way that you did this in Algebra 1, Algebra 2, and Pre-Calc, that's fine. If you've transitioned over to this function notation from calculus, that's great too. So they really are the same thing. They really, really are. Let's talk about what we know. Well, our A is really theta. So theta is pi over 4. That's going to be our A. We need our f of A, which is really the y. So that's tangent of pi over 4, secant of pi over 4. And this is our f of A. So let's evaluate this. Pi over 4 on your unit circle, excuse me guys, is over here. It's in the first quadrant. The ordered pair is root 2 over 2, root 2 over 2. And that's another one of those things you want to have memorized. So I have a unit circle I can pop into our Google Classroom. If you have one from Pre-Calc, it's the same one. You can print it out and use it. You'll want it nearby. Tangent of pi over 4 is root 2 over 2. Secant is related to cosine. Cosine is your x-coordinate, but you want the reciprocal of it. You're going to flip it over. So it's 2 over root 2, 2 over root 2. So if I've got root 2 over 2 and 2 over root 2, oh, I did tangent wrong, didn't I? Oh, I totally did. It's 7 o'clock in the morning at my house. All right, my tangent is incorrect. What should it be? Y over x, it should be a 1. That's better. So if we look at this, this is 2 over root 2. Now, I could go back and get that radical out of the denominator. I'm not going to be so worried about that right now. We'll see what happens later. If we need to rationalize the denominator later, we will. That's fine. All right, what are we talking about next? We need f prime of A. We need a derivative. We need a slope. So f prime of A, let's go with f prime of theta for now, is the derivative of the original. I have a tangent times a secant, so that's a product rule. The first term is theta, tangent theta. G prime, the derivative of secant, is secant theta, tangent theta. G is secant theta. And f prime is the derivative of the first one, the derivative of tangent is secant squared. Okay, now that's the derivative. I technically don't have to simplify anything with that, but I want to make my life a little bit easier. I see that everybody has a secant, so I'm going to factor a secant to the front. And then I've got a tangent squared theta plus a secant squared theta. Just makes my life a little bit easier. Now, I'm looking at a tangent squared plus secant squared, and yes, you want to be aware of those Pythagorean trig identities. Everybody's favorite is sine squared plus cosine squared equals 1. There is an identity out there with the tangent squared and the secant squared, but this does not equal 1 at this point. So I'm going to just let it go. The signs don't match appropriately. But what I am going to do is substitute that pi over 4. That will get me the actual slope that we need. Secant pi over 4, tangent of pi over 4. It's the whole quantity squared. And secant of pi over 4 squared. Okay. So secant, again, is related to cosine, right? And my cosine term is this green one over here. We highlighted this guy. Cosine is root 2 over 2, but for secant, we need the reciprocal of it. So maybe we'll make this green too. This is root 2 over 2. And I've got another one of those over here. This is root 2 over 2 quantity squared. And then tangent, remember I goofed that one up the first time. Tangent is y over x. So y over x is root 2 over 2, root 2 over 2. This is all 1. Okay. Maybe you write smaller than I do. F prime of pi over 4 is equal to root 2 over 2. 1 plus root 2 over 2 squared. This is 2 over 4 is a 1/2. So 1 plus 1/2 is 3/2. So this is 3/2. Now when I multiply, I've got 3 root 2 over 4. Now, a couple things. If you need your calculator to help out with fractions, no problem. Just you don't want decimal numbers here. You want to keep things as specific as possible. And as soon as you have a decimal and round it, you are no longer mathematically as precise as you can be. The square root of 2 is much more accurate than its decimal approximation. So this f prime of pi over 4, remember this is your derivative, this is your slope. So now we have to put all of this together, and I've written so much that I've run out of space here. So if we go back to our original point slope form, we have f of x minus f of a is that 2 over root 2 equal to my slope, which is 3 root 2 over 4 times x minus a, which is pi over 4. That is kind of an ugly equation of a line, but it is correct. I've not written any of these in point slope form. This is our last example, so we have a minute to do that. Or this is point slope, but slope intercept, excuse me. If I distribute my 3 root 2, I've got 3 root 2 over 4x minus 3 root 2 over 4 pi over 4. And then I can add this root 2. 3 root 2 over 4x. I'm going to put that over 16. 3 root 2 over 16. 16 pi plus 3 over root 2. Oh, I'm looking at this and I can actually go further. Now if I rationalize that denominator, I don't know, it's early morning. I feel like doing math, I guess. This would be 3 root 2 over 2. I could make this a common denominator. If I need an 8, so 24 root 2 over 8. And then it would look kind of funny. But you could put them together. Nope, not over 8, over 16. And you could have a root 2 over 16 negative 3 pi plus 24. Yeah, it doesn't do a whole lot for you, but that would be y equals mx plus b. So I would probably stop back up here at point slope form. Point slope form is always acceptable in the AP exam. So I would take that. There you go. In your Edpuzzle, I did put in a few multiple choice questions today. I thought it was kind of good practice to get immediate feedback. You know, am I on the right track? Am I not on the right track? How am I doing? So it doesn't count for grade for class at this point, but it's just kind of feedback for you. So there you go. Keep it up. Keep asking questions. Keep emailing me. Reach out to Mrs. Oakes. Zoom either one of us, but we'll get you through this.